Good day, everyone. Today, what we are going to discuss with this video learning is all about differentiation. And with this, I hope you're able to learn something with this video learning episode. To start with, the question here is, what does it mean when we talk about to differentiate in calculus? Basically, when we talk about to differentiate, something means to take the derivative. That is, taking the derivative of a function is the same as finding the slope at any point. So, differentiating is just finding the slope. And with this lesson, we are going to integrate or we are going to apply the four-step rule in differentiation or finding the derivative of a given function. Okay. Now, what are the four procedures or what is the four-step rule in differentiation? Now, here are the following procedures or steps in finding the derivative, or if we are going to differentiate the given function. Number one, or step number one, you have to substitute x plus delta x for the variable x of the given function and y plus delta y for the variable y in the given y is equal to f of x, which is our function. I repeat, the first step is that you have to replace our variable x with x plus delta x. Okay? And then for the variable y, we are going to replace the variable y by y plus delta y. Okay? And then after that, step number two is that you have to subtract the given function from the result of step one. And how are we going to do that? Remember that when we replace y by y plus delta y, therefore you have to transpose now y on the right side of our equation. Okay? So that we are going to obtain delta y in terms of x and delta x. Okay? I repeat, for step number two, our objective here is to get the value of delta y in terms of x and delta x. Step number three, you have to divide both sides of step number two. Now, whatever be the value that we obtained from step number two, we are just going to divide it by delta x so that we are going to have step number three. Okay, then the last step will be to find the limit of the result that we obtained from step number three as delta x approaches zero. Okay, now I repeat, these are the procedures in finding the differentiation of a given function. Okay, now to start with, let's proceed with our example number one. Now, given the function f of x is equal to x squared plus 3x, now we can also rewrite the given f of x as y. Therefore, instead of writing f of x, we can write it as y is equal to x squared plus 3x. Okay? Then, step number one, we are going to replace the variable x or substitute the variable x with x plus delta x. And for y, we do have y plus delta y. Okay? Therefore, in the given variable x, it will be replaced by x plus delta x. And for the y, we do have y plus delta y. Okay? Therefore, applying the step number one, we already have y plus delta y is equal to the square of x plus delta x plus 3, the quantity of x plus delta x. Then after that, we are going to simplify the given square of x plus delta x. Same thing with 3 times the quantity x plus delta x by applying square of binomial and distributive property. Okay, therefore, we do have the square of the given binomial is equal to x squared plus 2x delta x plus delta x squared. On the other hand, 3 times the quantity x plus delta x is equal to 3 times x, 3x, plus 3 times delta x, we do have 3 delta x. Therefore, this is now our result for step number 1. Then we are now going to proceed with step number 2. Now, for step number 2, we are going to subtract. Or first, we are going to transpose the given y on the right side of our equation. Okay? How are we going to do that? The variable y here will be transposed on the right side of our equation. Therefore, this will become delta y is equal to x squared plus 2x delta x plus delta x squared plus 3x plus 3 delta x minus y. What happened when we transpose? Since our y is positive, when we transpose it, it will become negative. Okay? And since class that y is equal to x squared plus 3x, hence we can now replace our y as x squared plus 3x. Therefore, we do have minus y. Since y is x squared plus 3x, therefore we can have the quantity x squared plus 3x. Then, apply now distributive property here. Because this is under subtraction, we can also have change the sign of our subtrahend. Okay? Now we can multiply it by -1 or change the sign of the subtrahend. Therefore, we do have minus x squared minus 3x. Therefore, delta y is equal to x squared plus 2x delta x plus delta x squared plus 3x plus 3 delta x minus x squared minus 3x. Okay? And then, after that, we are going to find the common or like terms of the given um, terms in the given equation. We do have x squared and we have negative x squared. They are like terms, okay, but they are opposing, okay, opposing to each other. One is positive x squared, the other one is negative x squared. And then we also have 3x, and then we do have the negative 3x. Okay, then after that, we are going to add the given like terms. We do have x squared minus x squared. The answer is 0. 3x minus 3x, the answer is 0. Therefore, what left will be 2x squared, 2x delta x plus delta x squared plus 3 delta x. I repeat, what left here in our given is that we do have 2x delta x plus delta x squared plus 3 delta x. And this is now our result for step number 2. Then we proceed with step number 3. For step number 3, whatever be the result that we have, we are going to divide both sides by delta x. Okay. Now we do have divide by delta x. Okay. Now, why do we have to do that? Because remember that delta y over delta x, okay, delta y over delta x is what we call the rate of change or the slope, okay? The change of y over the change of x. That's why we divide both sides by delta x. And applying the concept of division, we do have 2x delta x divided by delta x, what left is 2x. Delta x squared divided by delta x, what left is delta x as our quotient. 3 delta x divided by delta x, then we do have 3. Therefore, delta y over the delta x is equal to 2x plus delta x plus 3. Okay? And remember, y prime is equal to the first derivative, which is equal to the delta y over the delta x. Okay? Then step number 4, we are now going to get the limit as delta x approaches 0. Okay? Now, since we do have delta x as x approaches 0 is equal now to 2x plus 0. Okay, after substitution plus 3. Thus, we do have the rate of change or the first derivative or the differentiation of the given function now here is equal to 2x plus 3. Hence, the given function f of x is equal to x squared plus 3x to have the first derivative or the rate of change or the slope of the given function is equal to 2x plus 3. Now, I hope you're able to get the learning or the concept in dealing with differentiation using four-step rule. And here is now the four-step rule in differentiation. We do have step number 1. You are going to replace our variable x by x plus delta x. And for y, we do have y plus delta y. Then after that, find delta y in terms of x and delta x by transposing or through subtracting the given function. Okay? And then divide both sides, whatever be the result that we obtained from step number 2 by delta x. Then apply now the limit as delta x approaches 0 from our result of step number 3. Okay, another example that we have is f of x is equal to 5x squared minus 3x plus 4. We can also rewrite that one as y is equal to 5x squared minus 3x plus 4. And applying the four-step rule, we do have step number 1. We are going to replace the variable x by x plus delta x. And for y, we do have y plus delta y in a given function, which is y is equal to 5x squared minus 3x plus 4. Thus, we do have y plus delta y. Okay, we replace y by the given y plus delta y. And then, for the variable x, we do have x plus delta x. Open and close parenthesis, then raised by 2, or the square of x plus delta x. Minus, for the 3x, since we do have the variable x here, we are also going to replace it by x plus delta x, plus we do have the constant here, 4. Okay, then after that, we are going to simplify. Therefore, what we have is 5 times the quantity x squared plus 2x delta x plus the square of delta x minus we have 3 times the quantity x plus delta x plus 4. Okay? Then, apply now distributive property. 5 times x squared, 5x squared. 5 times 2x times delta x, we do have 10x delta x plus 5 times delta x squared. Okay? Now, in this term, we do have negative 3 times x, negative 3x. Negative 3 times delta x, we do have negative 3 delta x plus 4. Okay? Therefore, this is now our result for step number 1. Okay, after that, we proceed with step number 2. Okay, by doing in our obtained result, the variable y here will be transposed on the right side, making it delta y is equal to 5x squared plus 10x delta x plus 5 delta x squared minus 3x minus 3 delta x plus 4 minus y. I repeat, we have to transpose it so that we can able to subtract the given function. Okay? And what happened to our y? Okay, the sign changes from positive, it will become negative. That's why we write minus y. Okay? Then we have to remember that our y is equal to 5x squared minus 3x plus 4. Therefore, we can now replace it. Okay? We are going to replace it by, okay, 5x squared minus 3x plus 4. Open and close parenthesis. Okay, then we are going to simplify now. Okay, we have minus 5x squared plus 3x plus, okay, this will become minus 4. Okay, I repeat, minus 5x squared plus 3x minus 4. Then after that, we are going to combine like terms. Okay, thus we do have, for 5x squared, we do have minus 5x squared. Okay, minus 3x, we do have plus 3x. Then we do have plus 4, we do have minus 4. Okay, therefore, combining, we have 5x squared minus 5x squared. We have 0, negative 3x, positive 3x, 0. 4 positive minus 4, 0. And then what left will be 10x delta x plus 5 delta x squared minus 3 delta x. And this is now our result for step number 2. Okay? Then after that, we proceed with step number 3. Okay, we are going to divide the result in step number 2 by delta x. Okay, therefore, applying the concept, we divide both sides by delta x. Okay, now 10x delta x divided by delta x, what left will be 10x. 5 delta x squared divided by delta x, we do have 5 delta x. Minus 3 delta x divided by delta x, we do have minus 3. Therefore, here is now our result. 10x plus delta x minus 3. Okay? Now, this is for step number 3. Okay? And is a note for everyone. Okay? Then, for step number 4, we are going to apply now the limit as delta x approaches 0. Okay? Therefore, we do have 10x plus 5 times 0 minus 3. Now, any number multiplied to 0 will become 0. Therefore, what left will be 10x minus 3. Therefore, our result will be the differentiation of the given function 5x squared minus 3x plus 4 is equal to 10x minus 3. Yan. Okay? I hope you learned something with this example number 2. And if we are asked to find for the differentiation using the 4-step rule, we can able to apply the concept. Okay? And for your evaluation, or if you want to try finding the correct answer, or knowing what we learned in the differentiation, you can try this one. Okay? Now, find the differentiation of the following functions using 4-step rule. Okay, we do have f of x is equal to 5x minus 4 The second is f of x is equal to 7x squared minus 5x plus 4. The third one is f of x is equal to the square of x minus 3. And the last one is f of x is equal to 1 over x. Okay, let us now see the result of our performance task by looking the solutions that I provided for items number 1 to number 4. Let's start with f of x is equal to 5x minus 4. We can also rewrite that one into y is equal to 5x minus 4. Therefore, step number 1, this is now our result. We apply now, we already replaced y by y plus delta y, and for the variable x, we do have x plus delta x. And for step number 2, okay, we do have delta y is equal to 5 delta x. And then step number 3, okay, by dividing both sides by delta x, then we do have delta y over delta x is equal to 5. Okay? And for step number 4, we are now going to apply the limit as delta x approaches to 0. Therefore, our answer now will be our differentiation is equal to 5. Hence, the function f of x is equal to 5x minus 4 do have a first derivative of 5. Okay? Next, let's proceed with number 2. Okay? We do have f of x is equal to 7x squared minus 5x plus 4. By step number 1, we already have this answer. And then step number 2. Now here is now our result for step number 2. Okay. Then step number 3, dividing both sides by delta x. Therefore, the result now here is 4x plus 7 delta x minus 5. And applying the limit as delta x approaches to 0. Therefore, we do have 14x minus 5. Hence, the derivative of the given 7x squared minus 5x plus 4 is equal to 14x minus 5. Okay, now we go with number 3. We have f of x is equal to the square of x minus 3. Now by rewriting, we can have y is equal to the square of x minus 3. Now before I apply the 4 steps, I have to simplify first this one. This is the same as y is equal to x squared minus 6x plus 9 by applying the square of binomial. Then we proceed with step number 1. Here is now our result for step number 1. Okay. And then step number 2. This will be the result for step number 2. Okay, then step number 3, applying the division by delta x. Therefore, the result will be 2x plus delta x minus 6. Okay, then apply now the limit where delta x approaches 0. Therefore, the result will become 2x minus 6. Hence, the derivative of the square of x minus 3 is equal to 2x minus 6. Okay. And for our last item, we do have f of x is equal to 1 over x. We can also rewrite it as y is equal to 1 over x. And let's apply with step number 1. Okay, then step number 2. Okay, now here we have to get the LCD so that we can now simplify our dissimilar fractions or the similar expressions. Okay. Then applying the LCD, we do have, okay, now this will be our result when we apply now the LCD. Okay, the LCD will be divided by x plus delta x. What left will be x times 1. We do have 1 times x. Minus the LCD will be divided by x. What left will be x plus delta x times 1. Now we do have 1 times x plus delta x. Okay, then we are going to simplify it. Okay, now we do have x times x. We do have x squared plus we do have x times delta x. We do have x delta x. On the other hand, in our numerator, we do have x minus x. This will become 0. What left will be negative delta x. Okay, and here is our result for step number 2. Okay, we proceed with step number 3. Okay, we divide both sides by delta x. Okay, now since we do have our divisor, delta x, then we can rewrite this one into a multiplication by getting the reciprocal of our delta x. Therefore, we do have times 1 over delta x. Okay, and since delta x and delta x is similar, therefore we can cancel out here. Okay, we can cancel out. We can cancel it. Therefore, delta x divided by delta x will become 1. And our numerator will be negative 1 because this will become 1. Negative 1 times 1, we have negative 1. On the other hand, for denominator, we do have x squared plus x delta x times 1. We do have x squared plus x delta x, applying the concept of identity for multiplication. And step number 4, we are now going to apply the limit as delta x approaches 0. Therefore, we do have x plus x delta x for the denominator. For the numerator, we do have negative 1. If our delta x approaches 0, this will become 0. And any number multiplied to 0 by 0 property is equal to 0. And when you add it to x squared, the answer will become x squared using identity for addition. Thus, our derivative for the given function 1 over x is equal to negative 1 all over x squared. Okay, now these are the answers for the given performance or the try exercises that we imposed. Okay, and I hope you learned something with our discussion about the 4-step rule in differentiation. With this, goodbye and God bless everyone. See you in my next learning video with Bahagharing Lexi.